Dear student, today we'll start chapter 7, that is triangle. In this chapter, we'll study how two triangles can be congruent. Chapter 7, triangle. Chapter 7, triangle. So, congruent means the shape and size of two triangles must be equal. If I say ABC is a triangle, then another triangle which is, for example, PQR must be same with ABC in all its respect. That is, all the sides of PQR and ABC must be same. AB must be equal to PQ, BC must be equal to QR, and AC must be equal to PR. As well as the angle A must be equal to P, B must be equal to Q, and C must be equal to R. Here we'll say angle A and angle P are corresponding angle. Similarly, side ABC is corresponding to the side PQ. That is, PQ is the corresponding side of AB. Similarly, BC is corresponding to QR and AC is the corresponding side of PR. 5 criterion here. First one is S. That is side. If all the sides of triangle ABC is equal to all the sides of PQR, then we will apply this SSS criterion. Number 2 is SAS. Means what? If I have two corresponding side of two triangles are equal. For example, AB is equal to PQ and BC is equal to QR, and thus angle between side AB and BC, that is B, must be equal to the angle between two sides PQ and QR, that is Q, is equal to this angle. Then we can only apply this SAS, means two side and the angle between these two sides. Third one is ASA, similar to this one. Here we'll consider two angles, for example angle B and angle C. So angle B is equal to angle Q, angle C is equal to angle R, and the side between angle B and C, that is BC, and the side between angle Q and R, that is QR, these two sides must be equal. This angle is equal to this angle is equal to this angle, and this side is equal to this side. Then only we can apply ASA, angle side angle. We can't apply ASA if you have these two angle and this side. Okay, for that we have another criterion, that is AAS. Here we can have any two angle and any side. Okay, for example A and A, these two angle and this side or this side. Here we will not consider this side. If you have to consider this side, then you will use this ASA. Okay, this angle is equal to this angle is equal to this angle, but this side is equal to this side, which is not in between these two angles. Then we can use AAS. Remember this. And last one, RHS. R means right triangle, H means hypotenuse, and S means side. This is only applicable in case of right triangle. Okay, only we can apply this one for right triangle, because you have hypotenuse and right triangle in case of right triangle only. Okay, so this was our basic introduction about this chapter. Now we'll start exercise 7.1. This is our first question from exercise 7.1. In quadrilateral ACBD, that is given in your figure, in quadrilateral ACBD, AC equal to AD, this AC is equal to AD, and AB bisect angle A. AB is the bisector of angle A, that means this angle is equal to this angle. Show that triangle ABC, this triangle is equal to triangle ABD. So see, this side is equal to this side, this is the common side, and these two angle must be equal since AB is the bisector. So we can apply here SAS. Okay, so first we will write given AC equal to AD and AB is the bisector of angle A. Next, to prove, this is the symbol of congruency. So to prove triangle ABC congruent triangle ABD. Okay, we don't need any construction here, so simply we'll proof. In triangle ABC and in triangle ABD. In triangle ABC and in triangle ABD. First see AC. See, first and third. Similarly, first and third. AC equal to AD. This one is given. AC equal to AD is given. So we'll write given. Next, the angle between them. Angle CAB. Angle CAB. See, I have written CAB. So you don't write BAD here. Why? Because see, CAB. Third one, first one, middle one. So third one, first one, middle one. It should be DAB. CAB is equal to DAB. What will write in the bracket? Since AB is the bisector. And the last one, AB is equal to AB. It is common side. So therefore we have done triangle ABC is congruent to triangle ABD. Within bracket we'll write by SAS criterion. SAS criterion. Okay, this part is done. Next, see one more question. What can you say about BC and BD? Okay, since these two triangles are congruent, we can say corresponding sides or corresponding parts of these two congruent triangle are also equal. Since corresponding parts of congruent triangles are equal. Therefore, see, if I say BC from here, if I say BC second and third, BD second and third, BC must be equal to BD according to the corresponding parts of congruent triangle. See, in our next questions, when we will solve, we will write just CPCT in place of corresponding parts of congruent triangle. We will only write by CPCT. Okay, so first one is done. We'll do the second. This is the second question. ABCD is a quadrilateral in which AD equal to BC. So you can see clearly ABCD is the quadrilateral. AD and BC are equal. and DAV means this angle is equal to CBA means this angle. These two angles are equal. We have to prove that triangle ABD is equal to triangle BAC. See, ABD this one, ABD this one, and BAC means this one. Here AD and BC are common, AD and BC are equal, it is given already. And AB and BA, the base of these two triangle, see, AB, BA, same. And this angle between the base and this side is equal. That means BAC equal to CBA. That is already given. Not BAC actually, BAD. BAD equal to, or DAB, you can also say DAB is equal to CBA. So two sides and the angle between them. So we can apply here SAS. So start with this one. After that we will see what to do with next two. So first you have to write given AD equal to BC and angle DAB is equal CBA. Then to prove number 1, triangle ABD congruent triangle BAC. Number 2, BD is equal AC. And number 3, angle ABD is equal angle BAC. Okay, so start with the first one. You don't need any construction here, so we will not write construction. Proof. First one, in triangle ABD and in triangle BAC, two sides are given, AD equal to BC. So first write AD equal to BC. This is given. C, AD first and last, BC first and last, it is given. Okay, and the angle between this and this, that is DAB, that is also given. DAB, if it is DAB, second one will be CBA. DAB, CBA, it is given. CBA given. And the common side, okay, common side, it will be AB first and second. Similarly BA and BA both are same, so AB equal to BA, common sides or common side. That's it. SAS. So you will write, therefore triangle ABD congruent triangle BAC within bracket by SAS criterion. Side, angle side. Okay. Number 2, BD equal to AC. Can I find BD, SC, BD, AC? So by CPCT you can write this. So we'll write, since triangle ABD congruent triangle BAC, therefore BD is equal to AC by CPCT. Another one, ABD. Can I find ABD? See, ABD, BAC, same. So again you will have to write, since triangle ABD. See, we are writing this again and again because two different questions are given, Roman 2, Roman 3. This way, these are given, that's why you have to write this. So since triangle ABD congruent triangle BAC, you can also write angle ABD is equal angle BAC by CPCT. Here also we'll write by CPCT. That's it, done. So in this question you have to show that CD bisect AB. But before that, AD and BC are two perpendiculars on side AB, and these two perpendicular are of equal length. That is, the side AD is equal to BC, and these two angles are equal. Since you have to show CD bisect AB, means what? OA and OB are equal. If we can show OA and OB equal, then only we can say na CD bisect AB. For that we have to show these two triangles are equal, that means congruent. If we can say these two triangle congruent, then only we can say their corresponding sides are also equal, that is OA and OB. How will you say these two triangle congruent? See, this side is equal to this side, this angle is equal to this angle, and this is the angle, vertically opposite angle. So these two angle and one side, okay, this side is not between two angles, so we'll apply AAS criterion here. So let's start. Given AD perpendicular AB, comma BC perpendicular AB, and AD equal to BC. To prove, show that CD bisects AB. Means if I say OA equal to OB, that means CD bisect AB. So to prove is OA equal to OB. Proof. In triangle, see, if I say OAD, then I have to say OBD. In triangle OAD and in triangle OBD. Okay, since we have to apply AAS, so we'll write angle OAD is equal angle OBD. OAD and OBD both are 90 degree, since they are perpendicular, since 90 degree. Okay, AAS, so this one is your first angle. Second angle, you have to write the second angle, AOD. So how will you write AOD? Middle, first and last. AOD is equal BOD. They are vertically, see, BOD, sorry, not BOD, this should be C, not OBD. C. Okay, OAD, OBC, C. Then AOD, AOD and BOC, not D. I've made a mistake here. Okay, vertically opposite angles. Don't write VOA, you have to write vertically opposite angles. Okay, two angles are done. Now AD equal to BC, AD BC, second and last AD equal to BC, given, this is given, that's it. Therefore triangle OAD is congruent to triangle OBC by AAS criterion. Since these two triangles are congruent, now by CPCT, therefore I can say OA is equal OB. How? By CPCT. Since OA equal to OB, then I can say na CD bisects AB. since it is given in your question, show that CD bisects AB. So we'll write that is CD bisects AB. That's it. This is question number 4. L and M are two parallel lines intersected by another pair of parallel lines P and Q. So see, you can see L and M are two parallel lines intersected by another pair of parallel lines, that is P and Q. These are parallel, P and Q are also parallel. You have to show triangle ABC and triangle CDA are congruent. So since these two lines are parallel, L and M, okay, these two lines are parallel and AC is their transversal. Since L and M forgot about P and Q, okay, just L and M are parallel lines and AC is their transversal. Then we can say this angle is equal to this angle. How? These two angles are alternate angle. That's why. Again, PQ is parallel, P and Q are parallel, and AC is again their transversal. In this case, this angle is equal to this angle. They are also alternate angle, and AC is the common side between them. Okay, so by this two angle and the side between them, we can say these two triangle are congruent. That means we will apply here ASA. Okay, so write given L parallel M and P parallel Q. To prove, triangle ABC congruent triangle CDA. Proof. In triangle ABC and in triangle CDA, in triangle ABC and in triangle CDA. So what can we say about this? So first, can we write ACB? If I write ACB, see, ACB first, third and second is equal to CAD. CAD, are they equal? ACB is equal CAD. Yes, alternate angles. Since alternate angles, here we are going to apply ASA. So in the middle we have to write the side. If the side is AC here, see, AC first and third. Here also you have to write first and third, CA. Don't write AC. AC equal to AC. Okay. So AC equal to CA. Common side. And another triangle. Sorry, another angle. Another angle means if I write BAC. BAC, middle first and third. BAC. BAC. It will be DCA. DCA. Yes, another alternate angle. Alternate angles. Therefore, I can say triangle ABC is congruent triangle CDA by ASA criterion. That's it. So this is our fifth question. Line L is the bisector of an angle A. Line L, this is your line L, is the bisector of angle A. Okay, bisector of angle A means what? This angle and this angle are equal. And B is any point on L. B is any point on L such that BP and BQ are two perpendiculars. Taking any point B on L, you have to draw two perpendiculars from B, one on AP, that means this side, and another on this side, AQ. Okay, now you have to show that triangle APB and AQB, these two triangles are congruent. How to show? See, this angle is 90 degree, this angle is 90 degree. These two angles are equal. This angle 90 degree equal to this one. These two angles are equal, and this is your common side, means AAS. Okay, so easily you can say these two triangles are congruent. So let's start. Given L is the bisector. L is the bisector of angle A, and BP perpendicular AP, comma BQ perpendicular AQ. To prove number 1, triangle APB congruent triangle AQB, and number 2 is BP equal BQ. So let's start proof. Number 1, in triangle APB and in triangle AQB, as I said, angle APB is equal angle AQB. Reason 90 degree, both of them are perpendiculars now, since 90 degree. Next one, angle PAB. Angle PAB is equal QAB. PAB is equal QAB. So reason is since L is the bisector. L is the bisector. And third one is AB equal to AB, common side. Common side. That's it. First one is done. Therefore, I can say triangle APB is congruent to triangle AQB by AAS criterion. Now come to second one. See, BP equal to BQ. From here I can clearly say BP equal to BQ. Now by CPCT. So since triangle APB is congruent triangle AQB, therefore BP is equal BQ by CPCT. Proved. Here one, that is, we can say that is B is equidistance from the arms of angle A. That's it for today. This is the last problem we have solved. In the next video we'll give some other problems also. Thank you.